Hey, Mr. Weasel, old gatekeeper here, bud. Got your Texas Star 667 here, which is now going to be a Texas Star 500. And so basically we didn't have any output. You wanted me to go ahead and do a full power wire upgrade for you, all the way to the back of the transformer. You did mention in your letter that you was going to be putting this in a car that's a computer. Here, let me turn this down a little bit.
Left over rather than extra copies that he made.
So you mentioned that you're going to be running this in a newer vehicle with a computer. So just to be extra safe, I put an extra wrap on the chokes here, which brought these up to around 25, 26 microhenries worth of inductance, which is close to triple the amount that there was in there. See, these right here were the chokes by factory, so you can see the size of the lead that's carrying the DC power to each 2 transistor section. From there, from this size lead to a 14 gauge lead. Okay, so the inductance is now tripled, close to tripled, and then you've also got a 43 bead on each power wire, which adds a little bit more. So that's going to definitely help keep the RF off the power wires a lot better than it was. Okay, so basically I hurried up and well, before I get to that, I went ahead and did the conversion for you. Here's the driver section. The transistors should still be good in this. We could, if you want to, we could trade this in towards the cost. Since the transistor will be good, I can give you how much a used 2290 would be. Because I like keeping these driver sections if I ever can. Because sometimes people will send 500s in that want driver sections added. So some guys would try to keep those parts without paying you for them. And then that's definitely not me. If I take any kind of parts out of these boxes that I know have value to them, I'm always going to give you a chance to trade it in to take some off the cost, or me send it back to you if you need it. So so I went ahead and did the conversion for you, the 500 conversion. Okay, and I went ahead and cleaned the box up too, because this box was fairly dirty. It was really like you'd been riding around. I'm sure you may live near a dirt road. I can pretty much tell, because it was that type of dirt. It wasn't a dust. It was a dirt from like a dirt road, and it was pretty dirty in here. You think dirt wouldn't find its way into these boxes since they're sealed, but you still got a little room around the switches and room through this hole right here. It's wild how dirt finds their way into places. It really is amazing when you think it's pretty much sealed. But anyway, so I had to clean the box up for you. It probably took 30-45 minutes to do that. I just went ahead and did a full cleaning to it. And so basically, to get down to it, brother, I checked to see which section was not giving output, and it was this section right here. So then I was hoping that you only had one blown transistor, but you don't. You have 2 blown transistors, and they are not blown all the way around. They're blown from base to emitter. Both base to emitter junctions are blown, which of course it don't matter if it's blown all the way around or base to emitter or collector to base. They don't work. Just to show that real quick.
1975, coming back from overseas after about 2 years, Long discovered there was a major flap of UFO sightings. It had occurred while he was gone.
See if I can hold my phone with my
researching UFOs in earnest.
With my throat here.
In 1980, he interviewed Kenneth Arnold in Boise, Idaho. Arnold's sighting of 9 UFOs over the Cascades in Washington State on June 24th, 1947, was the seminal event that ushered in the modern era.
All right, so that's letting you know pretty much the transistor is being read like a diode. And it shows you right there the blue, which is the emitter, is not even showing up. And I'll show you on a regular meter. I'll show you that here in a minute. So basically it's saying that it's still showing a connection from base to collector, but from base to emitter is blown. Alright, let's unhook that one. Hook up the next one.
Substantiated by photography and multiple witness observation. And by the way, in his book, he's got quite a number of these photographs of what appear to be orange balls of light. I guess that's the only way I can put it.
Dang it.
Accompanied, by the way, by sounds, which we have a short recording of. I think you're going to find that fascinating. And also, there is a relationship.
The same thing. Alright. A lot of times after I check it with the atlas, I'll go ahead and use the old school way, which is actually just as good when you're trying to read to see if a transistor is blown or not. Actually, if you ask me, it's a lot quicker just doing it this way. Alright. So, to check a transistor with a multimeter, you go to the diode. So I'm going to put the red lead on the base, the black lead on the collector, which is the top. And see, I get a reading. That's letting me know the transistor is turning on from base to collector. Alright, now I'm going to go to base to emitter.
Except the price. It's not cheap, but good things rarely are. So if you're fed up
no reading
and you want a real portable telephone, I suggest you call Bob.
And both of them are blown that way. So you got two blown transistors, bud. The second that I notice a transistor is blown, sorry, that's my phone, I go ahead and put the X on them so it won't cause me no confusion. Alright, man, so I got to go look through some of my used transistors, because I could tell by your note that you would not like to have to pay $70 for two new ones. I'm not even going to call and ask. I could tell by your words on there that you wouldn't want to have to pay that much money for two new ones. You just want to get this thing back up and working. I have no idea what caused this thing to fail on you, man. The only thing I was kind of iffy about, which you may have done this yourself, I don't know, but it was kind of unique. I had not seen an amp do this before. Come to me like this. But these screws were holding the top lid on, right? Okay. Well, the factory screws were inside. 4 of these factory screws were inside the box rolling around. Now, I don't really understand why the factory screws would have been inside the box and then the top on with different screws holding it in. I mean, I'm just saying, I hope to God that you wasn't running it with those factory screws inside. I wouldn't think so, because I mean, you could hear them moving around. I don't think you would hook it up hearing them moving around, but I have no way of knowing. I mean, I'm of course going to ask you when I give you a holler, but you know, if those factory screws were inside there, yeah, that could have caused a problem. but I don't know. Maybe the factory screws didn't fit anymore, and those screws did, and you were just sending the factory screws with it. I don't know. But other than that, I didn't really see any indication of why these two blew like that. Usually it'll just blow one transistor most of the time, but you do see this happening too sometimes. But something happened to cause the base to emitter junction fail. But all right, man, I'm gonna get you two Toshibas. I'm gonna have to lift the legs up on one of these right here to see where these are at, so I can try to get you one matching as close as possible. All right, bud, I'll be back. All right, brother, got her all done for you. Got you two matching used Toshibas. They are different lots, but they do match. Okay. I had to put you 4 new 330 picofarad caps, which are these caps right here. There were none on here, which I have no idea why. Every once in a while I'll see a Texas Star come around like that from the older ones like this. Now all the newer Texas Stars, they don't put them on there with the DEI versions. They've took them off for the DEIs for some reason. I don't know the technical reason for that. But, so I went ahead and put you at the 330 picofarad, I call them collector loads. Girl, calm down. I'm trying to do a video, okay? I'm trying to do a video. Always trying to get in the picture, getting in the limelight. Anyway, went ahead and soldered all the tabs right here, especially since they were dirty. And I cleaned them first. Went ahead and soldered them. That's just something I do with every Texas Star, older Texas Star, with these type switches, so these won't never oxidize and mess up your lights and everything. I thickened up the path right here to your output combiner. It's just something I like to always do. To me, it makes me feel better to have a little bit of thickness right here, because I have actually felt numerous times factory, when you've been running a Texas Star for a while, you can put your finger right here on this trace right here, coming here, and it'll be warm. Ever since I felt that, that's just something I automatically do with every Texas Star 400 through a 667. Because all of your output power of the amp comes from this combiner right here to this trace, flows down this trace, which normally, is something thinner than paper, up to this power switch and back to the relay. So I always like to thicken that up. Sorry about that. Alright, so just to show you real quick, and by the way, I put you 2 new lenses right here. This one was chipped a little bit up under the bottom of it, and this one was just very dirty and kind of faded out, so I just put you 2 new ones. These 2 look fine. I just left them on there. And I haven't fired up your Mod V yet, but just to show you that the Texas Star is all done and rocking and rolling. You should be able to get 500 watts PEP out of a 500, hitting it with a 4-watt radio. So let's go ahead and demonstrate that now. 500 watt slug. We're on the peak. We're on the peak now. Oh, over 500 watts. We should be showing about 100.5, $1.50 RMS right now at this level. RMS. Oh, that's the middle scale. Okay, so we're doing about 180 bird. Oh, oh, beautiful, beautiful. All right, man, so this thing's rocking and rolling, brother. And one last thing, I went ahead and put you 2 filter caps on each hot bus of each 2 transistor section right here. Sometimes you'll see Texas Star put a small 22 or 33 or 100 microfarad cap. I just always like to put 2 1000s. That's just for filtering noise or any type of ripple that may be coming from your power supply. Help with, just in case, you know, you got a little bit of dirty voltage, I like to call it. So I went ahead and put them in for you, man. So this thing's ready to rock and roll, big brother. So what I'm gonna do now, well, what I need to do is I need to give you a call and see if you want to change this front to a brand new Texas Star 500 front before I fix this. As you see, this is loose. Make sure she's keying right too. She's moving. Oh, oh, yeah, it ain't even working. Oh, yeah, something's wrong with the meter. Let me look down in here. Yeah, it looks like something's just wrong with the meter. So I need to give you a call, see if you want a new meter. I need to see if you want a new meter. Oh, yeah. Yeah, oh, it's getting stuck right there. Probably take it apart and fix it, but it ain't worth the time. So I'm going to give you a ring, see if you want a new front and a new meter. I know the cost of this is up a little bit because I had to put two Toshibas in there. But and these Toshibas are getting more and more scarce as each day goes by. So anyway, I'll check with you on that before I continue the video. And I'm going to check the Mod V. You said it works. You just wanted me to check it for you, make sure it's working right. I did notice that the variable's loose. See? It's loose, so I'm going to tighten that up, make sure it's doing what it's supposed to be doing. And if it is, and if it ain't, I'll look in there and do what I got to do. But I will be back with the Mod V hooked up to the 500 and let you see what this thing's doing. Alrighty. But I do know from your letter, I don't believe you're going to be using this to drive this. You said you got a radio, What is it? General Lee. Said you got General Lee. So. But still, I'm going to use it to drive it anyway, just so you can see that the amp is really doing what it's supposed to be doing on the top end. Alright, man. Another Texas Star made 10.8. Back on the air. There's all the parts I had to remove out of it. I'll be back. Well, I'm on the bed right now, but I'll be back tomorrow. Alrighty, Mr. Weasel. Got your new meter on there. And I've got you a front. This ain't a new front, but it is in very good condition. Very good condition. As you can tell, the only thing wrong with this front, there's a little bend up here on the front, so I can save you a little bit on that right there. And then here's yours right here. And I didn't even have any more 500s fronts brand new, so I'm gonna have to restock on some of them. I had some white lines, but I didn't have any like that. And there's the front that came off of it. It's a little rough condition, bent up a little bit too. Alright, man, so on to your Texas Star modulator. You just want me to double check everything. The variable was loose and it was kind of hanging down that way, and the knob was kind of coming off a little. I kind of secured that a little bit more, and other than that, you can tell somebody had fixed a dead short here for the power. I'm guess it probably shorted up on the board and they fixed the short. That's why you see this wire coming like that. But it works great, man. The modulator's working, doing what it's supposed to be doing. I'll show you right now. It's just a 4-watt radio, 250-watt slug. So we're looking at the top scale. The 10 is 100 watts. This is peak. Oh, excuse me. That's. Oh, I got the variable all the way down. I knew something was wrong. All right. This is peak. The 10 is 100 watts. Oh, so it's doing right there about 125 watts. It's the 15 would be 150. All right, and we'll go over to RMS. You should see around 30 or 40 watts RMS. Oh, there you go, about 40 bird. That's a 2290. If you see 40 bird from a 2290, you're doing real good. Real good. Oh, and the input, 5 watts slug and reverse. Oh, just a little bit of movement. So that's good, man. So I'll get the top put back on this and come right back, and I'm going to drive this into this and just let you see what the 500 is doing on the top end. So we'll be right back. All right, brother, I got them both hooked up together. Okay. I've got the 500 hooked up to my unregulated 100 amp supply on the medium tap. So it's pretty much got access probably to around 65, 70 amps if it wants it. And it is floating at 18.5 volts, which is probably hard to see because I got my flash on by accident. And it's kind of hard to see. You probably can see it right there. But anyway, it's going to drop to about 14.4 volts. Okay. Now, here's your RMS. We're driving about 120 peak, around 40 bird. Okay, so here's your RMS power. It's 1000 watt slug. We're looking at the bottom scale. Okay, so the 20 would be 200 watts. Oh, so we're hitting about 300 bird. Oh, sorry, the dead key's kind of low. It's making that mod B rattle a little bit. Oh, so a little bit over 300 bird. All right, here's your peak watch. You should be hitting around a kilowatt already. Oh, right there at 1,000 watts. Right there at it. And you ask yourself, how is this thing doing 1,000 PEP watts, you know? Well, it's because I'm working in a condition right here to where all my coax jumpers are cut to the exact precision velocity factor, and I'm on a power supply giving this thing as much power as it possibly wants. You know, and it actually could get a little bit more power if it wanted to. If I go and flip it up to the high tap, we're going to probably see even just a little bit more, because right now it's dropping to 14.4 volts. So I'm going to flip it over to the high tap on the same radio. And of course, you know, it's going to be off the scale or 1,000 watts, so we won't be looking at the peak. Now we're going to go to the RMS and see if it gained any RMS bird wattage, as we like to say. So it was doing about right there at 300. Oh, I see it's gained about 50 bird. So we're at 350 bird. Oh, that's at 16 volts, so the volts is a little high on that. But we're already at 350 bird, and I haven't even hooked up my hot radio, my Stickman Cobra 29. So just for S and giggles, as they say, I'm going to remove this coax right here and hook up my Stickman Cobra 29. And let me see, I don't even know if I got everything ready to go back here. Yeah, it looks like I do. Okay. Alright, this coax right here. Alright, so I'm going to go ahead and hook up my Stickman Cobra 29. We're going to turn this off just to make sure the Stickman is working. We're going to turn bench radio off, Stickman Cobra 29 on. So now we're basically doubling our RMS drive from 4 watts to 8 watts. Okay, so let's see if everything is going good. Oh, okay. Oh, all right. See, now we are doing. Oh, the bird meter shows us about 80 bird. Now that is absolutely phenomenal for a 2290, but it would be more accurate if I was reading it with a 250 watt slug or a 100 watt slug. It'd be a little bit more accurate. Okay, so all right, let's flip it over to RMS. Oh, excuse me, flip it over to RMS. Let's turn the 500 on, the now 500. Okay, now let's see what it's doing RMS. And I will look over and see what the voltage is dropping to also. Oh, goodness gracious. That thing is swinging 500 bird. All right, let's take a look at what the voltage drop is. Oh, 15.4 volts. Oh, about 520, 530 bird. So I would say this thing is ready to go. I love it when the Texas Star is running the way it's supposed to, man. I'm very happy to be able to do this for you, man. You can get this thing back in operation up there in the Tennessee hills of the Valentia state on that cap picking end. And I'll get these bad boys packaged up for you, shipped back to you. Okay. And just to let you know, if you ever are going to drive this amp as a high drive like I was just doing, which I mean I personally don't recommend doing, but if you ever do that, make sure you're in high drive mode, which is right this, the power button pressed in. Okay, now if you're on sideband, of course you'd have that pressed in, but if you're going to be running this amplifier with just a radio, then you can utilize this. You really don't need this pressed in if you're in high drive mode, or you could burn up the resistor in there, the attenuator circuit. You don't want to drive a whole lot of power into it with that, or it could blow the attenuator circuit. But this right here is going to implement some extra resistor, a resistor network, and make your variable enabled. You see what I'm saying? With this turned off, the variable's not enabled, and you're in high drive. But if you want to run it with just a radio and adjust your dead carrier, your total output, you can do it like that. That's the way they have it set up, which is really neat. A lot of your modern homemade amps aren't going to have it set up like this. It's just going to be a high drive, and there you go. All right, man, so I'm going to get the screws put in this thing. And one last look at the inside. Now it's all good and clean. Converted over from a 667 to a 500. Now you have twice to almost 3 times the inductance on your hot feed to help keep the RF, the ripple from the RF at 27 megacycles, or wherever you're going to be running it, 28 megacycles, off the power wires, feeding back into your house or your vehicle, etc., etc. And, you know, if you want to get all technical down to the point, you're looking at around 500 ohms. You want this to be at the lowest frequency that you're going to be using. So there's a calculator, a formula for that, which for this particular thing, I think the formula, once you work it out, it equals to around 10 to 15 microhenries, if I remember correctly. And I always like to give it a little extra if I can, around 20, 25 or so, maybe even 30 if you can get it up there. But a lot of people will use 61 core, not really understanding this concept, and you know, they'll be sitting under the calculation, and you know, 9 times out of 10 they're still going to be fine, but it's going to be a little bit more RF ripple, and the bigger the amp is, the more ripple, the more RF you'll have flowing on your DC line. But that's for another video. 73s, my friend. Got you a Toshiba 5-pill, a Toshiba 5-pill, converted down to a Toshiba 500, repaired. Get the 2 bad transistors right here. We really don't know why they popped. Both of them popped equally, but they did. You know, sometimes there are a lot of times there's a mystery of why things happen. All I know how to do is fix them. 73s to you, Mr. GK, the gatekeeper right here around Northeast Georgia. 73s, bye-bye.